Welcome back. On today's agenda is notes on trig ratios, some practice, and there's a Google form for homework. By the end of class today, you should be able to apply your knowledge of trig identities to real-life problems. So, we've seen this before throughout the lessons, but I just want to remind you that anytime that we're referencing an angle, the angle we're referencing, we're going to name it theta. So let's say that I went ahead and I graphed a point on the coordinate plane. And in this case, in this example, I'm only going to be focused in on the first quadrant. So notice here's my y-axis, here's my x-axis, and I'm only focused on a quarter of my circle. And then I went ahead and I plotted a point on the circle, xy. So notice I'm going from the origin to this point xy. That means the point xy, from the origin I moved x units to the right and then y units up to get to that point xy. And the distance between that point and then my origin is 1 unit. So considering my circle, and this is my theta, I'm going to go ahead and I'm going to label each side of my triangle based off of theta. So that means my x is my adjacent side, my y is my O, and then my 1 is my hypotenuse. So thinking about SOHCAHTOA, if I'm solving for y, notice I would be using sine because y is opposite and then I know my hypotenuse. And then substituting it back in, sine of theta is equal to y over 1. And then y divided by 1 is just y. And if I went ahead and I was solving for my x, notice x is my adjacent side, so I'd be using cosine. So cosine of theta is equal to my adjacent is x, my hypotenuse is 1. X divided by 1 is just 1. So cosine theta is just x, and then sine of theta is just y. This is important for the Pythagorean identity. So notice the Pythagorean theorem, we've talked about it before. It's a squared plus b squared is equal to c squared. But then again, I know based off of that last image that I can just call this a is x, right? And then b is my y. And then my c is my hypotenuse of 1. And from the last image, I know, though, that I could say cosine of theta is equal to x, and then sine of theta is equal to y. So then I can go ahead and I can substitute in, instead of using x, I can use cosine theta. And instead of using y, I can use sine theta. So I can rewrite this statement as cosine squared theta is plus sine squared theta is equal to 1. So this is an important Pythagorean identity that you guys are going to be using frequently in your pre-calculus class. So keep that in mind. So now let's use it. I'm going to say, given that you know cosine of theta is equal to 3/5, find sine of theta and tangent of theta. So again, going back to the identity, cosine squared theta plus sine squared theta is equal to 1. Well, I was given that cosine theta is equal to 3/5. So I can go ahead and I can substitute that value back into my equation because I know that value for certain. So 3/5 squared plus sine squared theta is equal to 1. And then because I want to go ahead and I want to make sure I can isolate sine squared theta, I'm going to square my 3/5, and that's going to give me 9 over 25 because 3 squared is 9 and 5 squared is 25. And then for this next step, I'm just going to go ahead and show it. Because my denominator in this fraction here is 25, I'm going to rewrite my 1 as 25 over 25 just to make it the algebra a little bit more straightforward. I want to get sine squared theta by itself, and so I need to get rid of this 9 over 25. So I'm going to go ahead and subtract 9 over 25 from both sides of my equation. So sine squared theta is equal to 16 over 25. But now I need to eliminate my square. Remember, the inverse operation for squaring is taking the square root. So I'm going to go ahead and square root both sides. And remember, when I square root both sides, that means that I'm square rooting the 16 and the 25. So sine of theta is equal to 4/5.